So the top section, a 0 is a function of the function is an x value that makes the answer 0. That's why they're also called solutions. So your zeros are also called solutions, x-intercepts, and roots. And when we get back from spring break, we'll talk about why they're also called roots. So you guys use your graphing calculators. Number 1, how many zeros does that have? 2. Where were they? 5, 0, and a negative 4, 0. If you just put 5 and negative 4, that also works. Number 2, how many zeros? 1. Where was it? 3, 0. At 3. Number 3. 0, none. Number 4. 2. Where were they? 2 and 5. Because it was x minus 2, x minus 5. Okay. So if I have zeros, how would I know how to find the axis of symmetry? In the middle of the two, how do you find the middle, right? Okay. The same, how many jumps between each one? Ryan, what did you say? Average them. The middle. If you're trying to find the middle of something, you are averaging. Axis of symmetry, the average of the zeros. So if you have 2 zeros, you add them together and you divide by 2, right? So similar process as yesterday, except they're asking us for vertex form given zeros. Yesterday, they were giving us the vertex for vertex form. They were giving us the zeros for intercept form. Now they're going to give us the zeros for vertex form. So I've got some more work to do, but the process essentially is the same. So if I have zeros at 2 and negative 6, what am I going to do to find my axis of symmetry? Average them. So 2 plus negative 6 is what? Negative 4 divided by 2. Negative 2. So I know that my vertex has an x value of negative 2. I don't know what my y value is yet. I know my a value. My a value is 1. So when I start to write my function, I know so far that if my a value is 1, I don't have to write it. I mean, I could if I wanted to, but I can just start with x. And if it's negative 2, what would I put? X plus or minus? Plus 2 squared plus k, because k is this value, right? So I don't know what k is yet. I've got to figure that out. Yesterday we were working on finding the a value. Well, we have it now. Do I have enough information to use to find that missing k? Yeah, what could I do? Plug in one of my points. Plug in one of my points. Which one looks like an easier point? Plug in. 2, 0. Let's do it. So my x is going to be 2. My y is going to be 0. So go in and replace your x and your y with one of your points. Everything else remains the same. Because now the only unknown is k. And if you have one unknown, you can find it. 2 plus 2. 4. 4 squared. 16. So I have 0 equals 16 plus k. So k is equal to negative 16. So now I can go back to my vertex and say, okay, well, I know it's at negative 2, negative 16. Do I now have enough information to write my vertex form equation? Yes. It would be y equals, what would it be? 1 times plus 2 squared minus 16. And that's my answer. So like I said yesterday, process is the same, you're just missing something different. So let's flip over to the back because A is not always 1, right? Looking at number 5. Looking at number 5. First step. Average my zeros. It's 0. Everybody agree with that? Negative 5 plus 5 divided by 2, 0. So my vertex is at 0 something. My a value is negative 1. So let's get a starting point. Y equals negative 1 times x minus 0 squared plus k. X minus 0, how can I write that? X squared. Okay. Pick a point. 5, 0. Okay. So what's my y value going to be? 0. What's my x value going to be? 5. Squared? 25 times negative 1. Negative 25 plus k equals 0. So let's add 25, so k is 25. So now I know my vertex is at 0, 25. So I can write my function. I'm not going to mess with this x minus 0 business. I already know I can just write x squared. So my equation, y equals negative x squared plus 25. So this is a scenario where your standard form and your vertex form are the same. The vertex is the y-intercept. If you gave me an answer that looked like this, you would lose no points. That's right. Okay? So if this doesn't make sense, like, oh, we got it, and you leave it like that, you're good. This is correct. But you just don't need to put -0. All right. Last one together. Number 7. Let's average some zeros. Negative 7 halves plus 3 halves. It's negative 4 halves, which is negative 2. Over 2 is negative 1. So my vertex has an x value of negative 1. We don't know what the y value is. So let's start a function. Y equals 4 times x plus 1 squared plus k. Pick a point.
Is it negative 2?
Because because when you add it, it would give you negative 4 over 2, which is negative 2, and then I averaged it. So negative 4 over 2 is the sum. And we simplified it to negative 2 and then divided by 2. Okay. Pick a point.
3 over 2.
3 over 2. All right. What's my y value? 0. My x value. 3 over 2. Here's where it gets fun. What's 3 over 2 plus 1? 5 over 2 squared. 25 over 4. You have to square both. So we've got 0 equals 4 times 25 over 4 plus k. I mean, you guys have a calculator, so you can just multiply those, but we know that this happens, right? So it's just 25 plus k. So k is negative 25. What I was doing. Okay. Hmm? Yeah. Yes, decimals are always okay unless you have denominators of 36 or not. All right. And 7 is sometimes nasty too. Alright, we've got y equals 4 times x plus 1 squared minus 25. It's not bad. It's just long.
I feel like the hardest part would be memorizing
Yeah.
The formula's on the formula chart. Hold on a second. What restroom? Do one of the problems in the numerator.